Welcome back to our tutorial series. In this video, we're going to move into config files and file delivery, and specifically talk about file integrity. Now, we've already talked about exporting and importing files to and from Itembase, but so far, we've done it in a very simple way, exporting a file, downloading it, and sending it to someone. That works for small setups, but it's not how a larger team usually wants to work. There's a much cleaner and more reliable approach, and that's what we're going to learn now. We'll talk about where these files should live, how to deliver them to your team in a structured way, and how to make sure your exported files are never accidentally broken so you never end up breaking your game just because a bad file was exported. Let's start by looking at the config files page. Previously, we ran an export script, downloaded the file, and then probably sent it to a teammate through Slack or some other messenger. Config files allow us to store these files directly inside Itembase. That way, your team can come back later, access the files from a single place, and download them whenever they need. In practice, this becomes a permanent storage for your configuration files that can even be served directly to your game. To do this, let's first create a folder structure. We go to Config Files, and we create a new folder called Export. You can name it however you want, but in this case, we'll use export to store all files that are generated for our engineers. Earlier, we created an export script for boosts in the concept types section. Right now, if you simply click export, it generates the XML file and downloads it. What we want instead is to also save that file into our config files. To do that, we go back to the export config in the boost concept type. Here, you'll see a checkbox called Save Config File. We enable it, and then we provide a file path. So we write /export/boosts.xml. It's important to use the correct file extension, since this is an XML file. We save this and update the concept type. Now, every time we click export, the file will still download locally if we want it to, but it will also be saved automatically in the export folder. That means boosts.xml is now available to everyone on the team. We can download it, preview it, or open it in edit mode to inspect what's inside. We can even view it in a spreadsheet-style editor. Unlike normal spreadsheets, which are flat, this XML file has depth. So when you open it, you can drill down into nested sections, for example, into the stats block, and inside that you'll see values like ATK, HP, DEF, and luck. This makes it much easier to inspect complex structured files. This is already a much better way to share files with your teammates. You can copy the file URL and send it to someone. You can open the raw content. You can copy a widget URL that opens a clean preview editor, so your colleague can review the file even if they're not actively working in Itembase. Now, when exporting files, we want to make sure that the output always matches the engineer's expectations. This is where schemas come in. In a previous tutorial, when we generated the export script, we provided an example XML structure to the LLM, so it knew exactly how the file should look. That example usually comes from the engineering team, but there's a cleaner way to handle this, and it helps guarantee file quality. Instead of engineers sending XML examples back and forth, they can work directly inside Itembase. Here's how. Engineers create their own folder inside config files, for example called schemas. This folder is for engineers. The export folder is for designers. Each team works in their own space. Inside the schemas folder, engineers create a new schema file, for example boosts.schema. They choose the schema type that matches the file format. For XML files, that might be an XML schema. For JSON files, it could be XOD or another JSON schema format. They paste the example structure into the file, including the stats section with ATK, HP, DEF, and luck. If there's an issue in the structure, they can fix it right there. Then they ask the system to generate a schema based on that example. This creates a formal definition of how the file must look. Engineers can review it, edit it if needed, and save it. Now, we have a schema that defines the exact expected format. Next, we go back to the actual exported file, for example boosts.xml. We edit the file settings and assign the schema to it. From this point on, this schema acts as a guardian. Anytime the file changes, it's validated against the schema. If something breaks, we know immediately. We can manually validate it or rely on automated checks. This brings us to data integrity. When we go to the data integrity section, we'll see that tests were automatically created for this schema and file pair. All we have to do is run the tests. If everything passes, we know the file matches exactly what engineers expect. If something fails, we'll be notified. These tests can even trigger Slack notifications, so the team knows right away if a file is broken. This ensures we never accidentally deliver a broken file to engineering. Beyond schema validation, we can also create custom integrity tests. For example, sometimes we don't care about file contents, we just need to make sure a file exists. Earlier, we created a script that exports general game data. Let's update that script so it autosaves a file called general.json in the root folder. We save the script and run it again. Now we can see general.json in config files. Next, we want to create an integrity test that simply checks whether this file exists. We go to data integrity and create a new test. We name it something like general data file existence. We assign it to the main test suite. Then we describe the logic to the LLM. Check if general.json exists. If it exists, the test passes. If it doesn't exist, the test fails. If it exists but is empty, return a warning. We generate the test, save it, and run all tests again. Everything passes. This shows how powerful the integrity system is. We now have fully automated checks that verify file existence, file structure, file correctness, and even partial problems via warnings. And that concludes our tutorial on config files and data integrity. This is how Itembase moves from a design tool to a production-grade data delivery system.